Hello ladies and gentlemen, this is Mr. Cunningham, and what we're going to be talking about today is Notes 13.3, which is over concentrations. So go ahead, take a minute or two, and I want you to try those two bell work questions, then come back and we'll go over our objectives and goals, and then start lesson 13.3. So now that you've had a chance to go over that bell work, what we're going to be doing today again is going over concentrations, or how we find concentrations of solutions. So sub-objective 1 says that you need to be able to define what percent by mass, molarity, and density are. You need to be able to solve for the percent by mass, molarity, or density of a solution. Those are our two objectives. And our goal is use percent by mass, molarity, and density to find moles. Okay? Again, we're still using moles just like we have for the past few units. So, by the end of the day today, you're going to know what these three type of solution concentration units are. Okay, we're going to go through each one of them, go over an equation for each one of them, and talk about how we can solve for different parts of that equation. So the first one we're going to go over is molarity. So on your notes page, what I'd like you to do is write down that molarity is represented by that capital M. So on your notes page it says molarity equals. Molarity is equal to moles of solute divided by liters of solution. Write that down on your notes page. So what this means is, this is the most common unit that we use in chemistry, is molarity. And what it means is how we calculate the molarity of a solution. Again, molarity is capital M, is we take our moles of solute and divide by our liters of solution. Now, that's how we find molarity. Now, using this equation, I could ask you to find, oh, how many moles? If I gave you the molarity and I gave you the liters of solution, I would expect you to be able to find moles. Okay, so we're going to go over how we use this equation and solve for molarity. So let's walk through an example problem of that. And again, make sure you follow along with me. So let's say that we have a solution, and it's prepared by dissolving 26.7 grams of sodium hydroxide in 650 milliliters of water. And the question is, what's the molarity of the sodium hydroxide? So again, go back to our equation. Molarity is defined as moles of solute divided by liters of solution. All right? Well, I was given grams of sodium hydroxide, and I was given milliliters of water. So neither of those units are in the things we need. We were given grams of sodium hydroxide, but we need moles. And again, what we have to first identify is, what's our solute? What is the thing that is being dissolved in the substance? Well, again, the solute, the thing being dissolved, is going to be the sodium hydroxide. All right? So I need to find how many moles of that I have. I have 26.7 grams. All right? Then this is going to be the volume of my solution, 650 milliliters, but it is not in liters. We're going to have to change that. So here are the first two things you need to do. First thing is, we need to change our grams of sodium hydroxide to moles of sodium hydroxide. Because if we are asked to find molarity, we have to take the moles of our solute and divide by the liters of our solution. Then we have to take our 650 milliliters of water, and we have to change that to liters of water. So, first part, this is again the dimensional analysis for changing grams of sodium hydroxide to moles. So this is how many grams of sodium hydroxide I was given in my problem. So what I need to do first is, I need to change from grams to moles, I have to divide by the molar mass. Well, since I'm dividing by the molar mass is going on the bottom here. Sodium hydroxide's molar mass is 40 grams per mole. So I'm going to take 26.7, divide by the molar mass of sodium hydroxide, which is 40. Notice how, since I'm setting this up using dimensional analysis, the grams of sodium hydroxide is going to cancel, and I will be left with moles of sodium hydroxide. So this unit here and this unit here would cancel out. This is the number of moles of sodium hydroxide I have. Okay? So again, molarity is moles of solute divided by liters of solution. I now know how many moles of solute dissolved. Okay? Next step is I have to change milliliters of water to liters of water. So I'm going to take my 650 milliliters, and I have to change that to liters. So I'm going to take 650, and I'm going to divide by 1,000, because I know that the conversion for milliliters to liters is 1 liter is 1,000 milliliters. Since this unit here was in milliliters, I knew that my 1,000 milliliters had to go on the bottom. So I would do 650 divided by 1,000, which means I have 0.650 liters. So now I have my moles of my solute. I have my liters of solution. Now I can actually use my molarity equation. So now I'm going to take my moles of solute, 0.6675, divided by my liters of solution, and that means the molarity of this solution, so I'd say that this molarity is 1.03 molar NaOH, or 1.03 molar sodium hydroxide. Okay? Let's look at the next type of problem. I'll give you guys a chance to practice these, but we're going to go through all three first, then we'll do some practice problems. The next type of solution concentration that that I'm going to expect you to be able to use is percent by mass. So percent by mass is very similar to what we did a few units ago, which is percent composition. Here's what percent by mass means. Percent by mass is equal to the mass of my solute divided by the mass of my solution, and then again, to change something to a percent, I multiply by 100. So write down this equation where it says percent by mass equals, or percent mass equals. Get that equation down, all right? So again, this equation, just like in the last one, remember molarity is equal to moles of solute. I have to identify what my solute is and what my solution is, all right? So here we go. So it says a solution is prepared by dissolving 36.4 grams of calcium iodide in 750 grams of water. What is the percent by mass of the solution? So in order to do this problem, I have to identify what thing is my solute, what's the thing getting dissolved, and what's the thing that is my solution. So remember, we have two things inside of a solution, right? A solution has two components. It has the solute and the solvent. So we want to know what the solute is. The solute is the thing getting dissolved. So it says that 36.4 grams of CAI is dissolving in this many grams of water. So the solute in my solution is the calcium iodide, right? That's my solute. The solution is my solute and my solvent. So again, if I'm dissolving 36.4 grams of calcium iodide in this many grams of water, this is my solute, the CAI, and the water is my solvent. So my solution is my calcium iodide and my water. So I need to find what their masses are. So I'm going to take the mass of my solute. Again, my solute was calcium iodide. How much mass of that did I have? That was 36.4 grams. And I'm going to divide by the mass of my solution. Okay, so again, mass of solute divided by mass of solution times 100. So my solute was CAI. So I'm going to take the 36.4. That goes on the top of my fraction. Then I'm going to divide by the mass of my solution. Well, if my solution is calcium iodide and water, then I need to add up their masses to get the mass of my solution. So then I would divide that. So I do 36.4 grams divided by my solute and solvent added together times 100, and that would give me 4.63%. So this would be my answer. The mass percent of calcium iodide in this solution is 4.63%, meaning 4.63% of this mass is calcium iodide. All right? It's the second type of problem you're going to be required to do in this unit. The third type is using density. So I want you to write down, again, this equation for density on your notes page. So density is equal to mass divided by volume. Now, mass could be in a bunch of different units. Volume can be in a bunch of different units. The thing that we use typically for mass is in grams, but mass could also be in kilograms. It could be in milligrams. The one that I will give you most often will be grams. So it's the mass divided by the volume. Now volume, the ones that we have seen have been in liters and milliliters. That's the units that you would probably see in these types of problems. So you're going to be looking for grams and probably milliliters or liters for my volume. All right? So that's the equation. Here's a problem. So it says, what is the density of a saltwater solution in grams per milliliter? Here's what that means. Okay, that's really important. Grams per milliliter means that if I'm going to use this equation, since it said my unit needs to be in grams per milliliter, again, this slash means per, so grams per milliliter, that means that my mass has to be in grams and my volume has to be in milliliters when I do this division. All right? Otherwise, I wouldn't get grams per milliliter. If I had grams, if I used my mass in grams and my volume in liters, then I would get grams per liter. All right? So my mass for this problem that I'm getting ready to do has to be in grams and my volume has to be in milliliters so that when the problem is over, my units are in grams per milliliter. So it says, so what is the density of a saltwater solution in grams per milliliter if the solution weighs 56.3 grams and occupies a volume of 0.0542 liters? Well, okay. So, again, it's density. So it's find your mass. Okay, so the solution has a mass of 56.3 grams. Since it wanted my unit in grams per milliliter, is this unit in grams? Yes, it is. So I'm good there. But this unit is not in milliliters. I have to change that to milliliters since it specifically told me it wanted my units to be in grams per milliliter. So I start with my 0.052 liters. And what I want you to, I guess, try and guess, or how should my dimensional analysis be set up here? I know that 1 liter is equal to 1,000 milliliters. So I'm going to set that up as a fraction. Does the 1 liter go on top and the 1,000 milliliters go on the bottom? Or does the 1,000 milliliters go on top and the 1 liter go on the bottom? You decide that. Well, what you should have said is you should have said that the 1 liter goes on the bottom. Again, the reason why that liter unit goes on the bottom is because we want these units to cancel. We want liters to disappear. That way we will only have milliliters left. Meaning I have to take 0.0542 and multiply by 1,000. That way I get my milliliters. So now I have my grams, and now I have my milliliters, because that's the unit the problem wanted me to be in when I finish. So now I'm going to take my 56.3 grams. I'm going to divide by my 42.2 milliliters. And what that gives me is that my density is 1.04 grams per milliliter. Here's what that unit means, all right? That unit means that if I had 1 milliliter of this solution, it would weigh 1.04 grams. Okay, because the density is 1.04 grams per milliliter, meaning 1.04 grams has a volume of 1 milliliter. Or if I had 1 milliliter of it, it would weigh 1.04 grams. Okay? So, what I want you guys to do is you're going to take a second, and this is a concept map for all of the units that I just went to. Now, you can I will have the Edpuzzle pause the video so that you can get this copied down, but I want to tell you guys, like, I want you to listen to this because it's really important. It's going through how we can convert from all these. So, all of these units are connected in some way. So if I was given the moles of my solution and I wanted to find the molarity, well, if I have my moles, okay, I can divide by my liters of solution, and that will give me molarity, because the equation for molarity is, again, moles of solute divided by liters of solution. So if I have my moles of solute and divide by my liters of solution, I get my molarity. Well, what if I wasn't given moles? Remember in our practice problem over molarity, I was given grams of something. Well, notice how this circle here says grams of my compound. All right? So if I have grams of a compound and it's asking me to find molarity, well, I need to change the grams of my compound to moles. And how I change grams to moles is by dividing by the molar mass. Again, along this arrow here, it says divide. Here is my molar mass. So if I take the grams of my substance and divide by the molar mass, I get moles. Then I take my moles and divide by my liters of solution, and I would get molarity. Now, I can also, really, these three circles right here help you relate all of the things in the molarity equation. Okay? In the molarity equation, it's molarity equals moles divided by liters. So if I wanted to find moles and I was given liters of solution, I would also have to be given molarity. And if I take my liters of solution and I'm trying to find moles, I would multiply by the molarity. Okay? In the same way, if I was given molarity and I wanted to find moles, I would need to know the liters of my solution. And if I knew the liters of my solution, I could take molarity times my liters of solution, and that would give me my moles of my substance. All right? So that's for the molarity section. For density, okay? Density, I can convert between density and the grams of now my solution. Now, here's a little disclaimer down here. So I'm going to read this for you. It says, solution can only be used for density. In other words, I'm not going to use grams of solution to go to moles and molarity and do all this stuff, okay? You will never find moles of a solution from grams of a solution. And here's why. You can't find grams of a solution from moles of a solution because in a solution, it's not a pure substance. A solution has multiple different things in it. Okay, so just because, so let me go back. I'm going to go back a slide here for you. When we did our density, so we found that the density of this saltwater solution was 1.04 grams per milliliter. But I cannot use this 1.4 grams per milliliter to find grams of my salt. And that's because this 1.04 gram per milliliter density isn't just salt. It has water in it as well. So I can't use that to find moles. That's what I'm meaning by that statement. But I can use it to find grams of my solution. Okay, so density, again, if I know grams of my solution and I know volume, then I can find my density. Okay, so again, the equation for density is mass divided by volume. So if I know my grams of solution, okay, if I know how much it weighs, and I know the volume of it, I just do mass of my solution divided by volume, and I get my density. Now this one's a little bit more complicated. To use the mass, anytime you're asked to use mass percent, what I would do is I would start with the equation, which is right here. I would plug in the values that you are given, and I would solve for something, for the thing that you're asked to solve for. So if it gave you the percent by mass, and it gave you the mass of solution, then I would manipulate this equation to solve for the mass of my solute. And I'll show you how to do that in these next few example problems. So go ahead, get this down if you haven't already, so that way you have it when you're doing our calculations. So let's go ahead and try this first problem. So it says, how many grams of lithium chloride are required to make 500 milliliters of a 3.00, and then again, this capital M means molar or molarity. So I have a 3.00 molar solution. All right, so let's go ahead and let's try this problem. I'm going to work right here. I'm going to actually show you maybe two ways of thinking about this problem. So let's start this first way. So the first way that you can do this type of problem is you can solve it and think about it like as an equation. Okay, so again, because we are given molarity, right? We are given molarity here, and we are given a volume here. So initially what you should think about is, oh, if I'm given molarity, I need to think about the molarity equation. So I'm going to write that down first. So I know that molarity, which is represented by capital M, is equal to moles over liters of solution. So the moles of solute divided by liters of solution. So I'm going to go back, look at my problem, and go, okay, what is my solute? Well, it's lithium chloride. Okay, it said that lithium chloride was in that solution. I'm given my molarity and I'm given my volume, but it is not in liters. Okay, so I'm going to plug in the values that I know. I know that I have a 3.00 molar solution, and I know that my liter amount, I'm not given liters, but I'm given milliliters. Now remember, I can't plug in 500 here, okay? Because molarity is moles per liter. So just to save time, this is actually going to end up being 0.5 liters. Again, to change from milliliters to liters, you divide by 1,000. So this is going to be 0.5 liters. Which leaves me with moles to solve for. Now you might be like, well, how'd you know to solve for moles? Well, it asked me how many grams of lithium chloride. Well, I can't solve directly for grams, but here's what I know I can do. I can solve for moles of lithium chloride. So again, lithium chloride was the solute. So I'm really solving for moles of lithium chloride. Then, once I know moles of lithium chloride, I can solve for my grams. Okay? So, I'm going to manipulate this equation again to solve for moles of lithium chloride. I could just put this in as, say, x, right? Just like in any equation, solving for a variable. So I'm going to multiply both sides by 0.5. And that's going to give me that my molarity, these are going to cancel right here. So 0.5 times 3 is 1.5, so 1.5 equals x. Now you always have to ask yourself, what does this x mean? What does it stand for? Well, this is moles. So I have 1.5 moles of lithium chloride. But the problem didn't ask me to find moles. It asked me to find grams. So now what I'm going to do is I'm going to take my 1.5 moles of lithium chloride, and how do I change from moles to grams? Well, if you use your mole map, hopefully you've memorized this by now. To change from moles to grams, I multiply by the molar mass. So if I was setting up my dimensional analysis, I know that I have that 1 mole of lithium chloride. I went ahead and added this up already. The molar mass of lithium chloride is 42.39. So I would take my 1.5 moles of lithium chloride, multiply by 42.39, and that's going to tell me how many grams I would need to dissolve in my solution. Okay? So that's how many grams are in that solution, and I get 63.59. This is the amount of grams that I would need in that solution. Or in other words, the problem asked me how many grams of lithium chloride are required to make that solution. That's how many grams would be required. Okay? Now, I told you I'd walk you through another way. Okay? So, this one is going to be using the mole map. So I'm going to go back to this. Now, here's how you could use the mole map to solve that question. You go, okay, what did it ask me to find? It said how many grams, right? Grams of compound is right here. So I'm going to be ending here. So I'm going to put an E there for end. Well, where am I starting? Okay, what was I given? Well, I was given molarity, and I was given my liters of solution, right? So really, I could start in one of these two spots. Okay, now, I'm going to choose to start right here in molarity. Okay? So, what was the molarity of my solution? It was 3, right? 3.00, so I had 3.00, and that was molar, so that's why I'm starting here. Then it says, if I want to change from molarity to moles, I need to multiply by liters of solution. Well, what was my liters of solution? Remember, it gave me 500 milliliters. That's not my liters of solution, that's my milliliters. So what I would do is I'd take my 3.0 and I have to multiply by my liters, which again was 0.5 liters. So I'd take 3.0 and I would multiply by, this was 0.5 liters. So I take 3 times 0.5, and that's going to give me my moles. Well, remember my moles was 1.5 moles. Then, to change from moles to grams of my compound, I would have to take my 1.5 and now follow it to this circle, and following that arrow, I have multiplication. So I'd have to take 1.5 and I would have to multiply by the molar mass of that compound. And remember, the molar mass of my compound was 42.39. So I would multiply by 42.39, and that would give me my ending amount, my grams. And again, the gram amount that we got was 63.59. That would be my answer here. So you can use the mole map, or you can use the equation method. Both work. Okay? I would say that this one might be a little bit easier and help you make some connections, but all of these things can be connected to one another. Okay, so that's our first problem. Oops. So let's look at this next one. Next one says, how much acetic acid must be in a 750 gram solution of water and acetic acid to make a 5% by mass solution? Okay, so again, let's go back to our mole map real quick. Anytime percent by mass is mentioned, what I want you guys to do is I want you to think about this equation. Okay, so we're going to put down this equation, we're going to plug in the stuff that we know, and then we'll manipulate it. So, here's our problem right here. I'm going to go ahead and write down my percent composition, or excuse me, my percent mass equation. So it's my percent mass is equal to mass of solute divided by mass of solution times 100. Right? That's my equation. So I'm going to go to this page now. So again, we're going to plug in the values that we're given, and then we're going to solve for the one we don't have. So it said, how much acetic acid must be in a 750 gram solution? Okay, so that's important. We have a 750 gram solution of water and acetic acid to make a 5% by mass solution. Okay, so it said it's 5% by mass. So I'm going to put in my 5 here. And I've got 750 grams of solution, so that's going to go on the bottom here. So I have a 5% by mass solution. I do not know the mass of my solute, so that's going to be X. And the mass of my solution was 750 grams. Then I leave in my times 100. Now, all I do is I solve this equation for X. Well, the first thing I could do is I could take 100, and I need to get rid of it. So, since it's being multiplied, I divide it to this side. So I do 5, so I divide by 100 on this side. I'm going to go ahead and get rid of this equation here. So I divide by 100 on this side. That's going to get rid of 100 here. This is going to give me 0.05. So now 0.05 equals X over 750. Now I multiply both sides by 750. These are going to cancel out here, and 0.05 times 750 is 37.5. Now, again, I always tell you, what does that X mean? Well, it means, remember what's on the top of the mass percent equation? It's mass of solute. And the question asked me, how much acetic acid must be in a 750 gram solution? Well, this is how much acetic acid, and because that X stands for mass of solute, this is going to be how many grams of acetic acid I would need. Alrighty? Let's go to the next problem. So here's our third problem. It says the density of an H2SO4 solution is 1.42 grams per milliliter. How many grams would a 500 milliliter solution weigh? So again, identify what you're given. This is the density. This is the volume, right? And it's saying how many grams. So it's asking for a mass. Let's go back and look at our mole map. Okay? I was given density and I was given volume. Right here. So to change from density, when I have density and volume, I can change to grams of my solution by just taking density times volume. So my density was 1.42 grams per milliliter. Oops. I'm going to write it, instead of writing it like that, I'm going to write it like this. So 1.42 grams for every 1 milliliter. Whoops, not mole, 1 milliliter. And I'm going to multiply that times the volume. And the volume was 500 milliliters. notice how this number, or this unit here, 500 milliliters, is on the top. This is on the bottom, so my milliliters are going to cancel. So now I just need to do 1.42 times 500. And that gives me 710. Because the only unit that's left is grams, that is how many grams a 500 milliliter solution would weigh. All right? So those are the 3 types of example problems that we have. So on our next slide, at the very bottom of your page, it looks something like this. Okay? Here's what I want you to do with this chart. Overall, the questions that I want you to do is I want you to find the mass percent and molarity of glucose in the solution. So I give you a bunch of information. Really what I want you guys to do is I want you to fill in everything about this chart that you can. First of all, identify what the solute and the solvent are. Okay? Then once you've identified what those things are, tell me how many, that's what these lines are for on your page, is write in what that is. Okay? So it says a solution used for intravenous feeding contains 4.8 grams of glucose. Then this is the formula, in 90 grams of water. So you've got glucose, you've got water. Which one's your solute, which one's your solvent? Then fill in the mass of each of those things. Okay? Then put in what your mass of solution is. Then change those masses, okay, of each thing to moles. Now, you will not fill in volume of solute, that's why I have an X there. And one thing I forgot to put an X in is your moles of solution. So you will not put something in this box either. Okay? Now, the volume of your solvent and the volume of your solution is going to be the same volume, because notice how it says assume that adding the glucose does not increase the volume of the solution. So whatever the volume of your solvent is also going to be the volume of your solution. So what I want you to do is go ahead, work through that. If you have any questions for me, make sure you let me know. It will show up, the answers for it will show up on Edpuzzle. I'll have like a picture with everything filled in. If you have any questions for me, please make sure you let me know. Again, the thing that you're trying to solve for, the main questions are calculate the mass percent and molarity of the glucose solution. Okay? So, thank you for watching. Hope that this video helps you be able to calculate some concentrations.